The first International Conference on Material and Energy, September 14, 2021, Tamrast, Algeria. The influence of temperature and solar drying kinetics of jujube leaves. Department of Matter Science, Faculty of Science and Technology, Tamrast University, Algeria. The Renewable Energy Research Unit in the Sahara Medium, Adrar, Algeria. Introduction. In this work, we study the effects of temperature on the drying kinetics of agricultural products such as jujube leaves, in order to create characteristic drying curves from the experimental results that have been carried out. Materials and methods. The jujube tree is a thorny and bushy shrub very abundant in both shores of the Mediterranean. Jujube leaves for their use must be dried. One of the methods is solar drying, which has many advantages over other forms of energy. The drying tests were carried out by preliminary measurement to determine the global solar radiation by using a panometer attached to the sensor. Different temperature in PET hybrid solar air corrector and ambient temperature using a type K thermocouple. We have weighed 15 grams as initial mass of separating jujube leaves to distribute in each rack inside the indirect solar dryer. Figure 1 is a photo represents a prototype of an indirect solar dryer by forced convection with a hybrid PV&T collector. This photo was taken in the MS Adrar Research Unit. Number 1 is the chimney, number 2 is the PV&T solar collector, and number 3 is the drying room. Figure 2 is the temperature evaluation of the indirect solar dryer. Result and discussion. Result shows an increase in the air temperature as it passes through the hybrid solar corrector in order to the drying room, which lead to the drying quickly and efficiently. The maximum temperature was recorded at 1314, figure 2, which corresponds to the true solar time, which is measurement of the time based on the apparent displacement of the sun during the day. The curves, figure 3, show that the mass of the sample to be dried decreases with time. After 6 hours, the mass increased from 14 grams to 25 grams. Then it stabilizes, which shows the absence of water after evaporation. It can be seen through the drying speed curves that the drying process is fast from samples do not contain a large amount of water. During the first hour of drying, lose 20% of the mass. Figure 3 represent drying speed curves which represent the mass value of sample to be dried as a function of the time after passing through the indirect air solar dryer. Conclusions. Jujubes or cedar leaves contain molecules with antibacterial, healing, and antidiabetic properties. For use, they must be dried. One of the methods is solar drying, which has many advantages over other forms of energy. Drying is conducted by an indirect solar dryer and a hybrid solar PV&T collector to produce heat necessary for drying and electricity for the hot air movement to the drying room and to evacuate the humid air. The drying speed is expressed as the mass loss of the dried products, or mu-stir loss over time. Results shows that the mu-stir loss is maximum at the beginning, then decrease to the point of stability where the drying is complete.